performance evaluations and expandability assessment of deep learning architectures for age-related macular degeneration diagnosis in OCT images. This research is collaborative work with my co-authors from Hamburg University and University of Texas at El Paso and the University of Cincinnati in the USA. To give you a roadmap of my presentation, here's the six main part that I want to cover. First is the introductions and problem statement, then the research objective, followed by the dataset and methodology. And after that, we're gonna talk about the model architectures and the results. And finally is the conclusion and our future work. So first, what is age-related macular degenerations or AMD for short terms? So this disease is an eye disease, and it happens when you're in your 50s. It's gonna affect the middle part of your eye, and this is one of the leading causes of the vision loss in the elderly. And we all know that there's a lot of nations had growing population, so the scientists have projected this disease gonna affect 170 million people by 2020. And the key stages of AMD is have two stages. The first stage is the dry AMD, as you can see here. Usually, you're gonna have the distorted vision at this stage due to the drusen formations, and the next stage is the wet AMD. In this stage, you're gonna have the blind spot in the center of field of visions, and why do we call it wet AMD? Is because in this state, abnormal blood vessel gonna form, and then it's gonna leak fluid. So the fluid that leak it gonna create that kind of blind spot that you can see at the picture. And another key point that I want to mention is that in the classification of this disease, we're going to have three classes. So the first one going to be the normal eye. The second is the dry AMD, or we can call it drusen. And the third one is the wet AMD. We call it choroidal neovascularization, or CNV for short. The next thing is about the role of OCT imaging. So what does OCT stand for? OCT is optical coherent tomography, and this is considered as the gold standard for non-invasive diagnosis of AMD. But we do have a very huge challenge here, is that we have a very large volume of OCT scan, but we only have a very limited number of ophthalmologists. So, how can we solve this challenge? We're going to need an automatic, reliable, and transparent AI diagnostic tool so that we can cope with the large volume of OCT scan. About the motivations and the problem statement, the first thing I want to talk is that the AI models, most of the AI models for medical imaging often remain as a black box. We don't really know where to focus on, the attention that the model actually